explain it to us all. I'd like to introduce you to Andy Dunne from the Laois Farm Forestry Group. Over to you, Andy. Andy, you're muted there.
We'll try now. Am I better now?
Perfect now, thank you.
Good. Good evening, everybody, and welcome to our last, I think, webinar of this series. Tonight, we are going to talk about carbon, and we have an interesting lineup. We'll start with a short kind of an introductory video, about 13 minutes long, which will set the scene for us. And after that, we will have presentations from Dr. David Stiles and Dr. Kevin Black, and we'll be joined for a discussion then by Professor Gary Lanigan. So without further ado, can we launch the movie, please?
Carbon sequestration is a hot topic around farming, so we went to meet Nicholas Roberts on his farm outside New Ross in County Wexford to learn more about it.
This is a dairy farm, was previously beef tillage, but it's now a dairy farm.
Okay, so this is a quiet time of year for you. You've got the feet up, you're relaxing.
I wish, yeah. But this is what you sign up for. Right. January, February, right through until March, April are very busy on a dairy farm, but that's it. It's great to see new life coming every year. And cows back out to grass and the start of the same routine then. Yeah. We all need to be sustainable now. It's the new buzzword and everything like that, but I suppose trees certainly have a role to play on every farm, be it dairy, tillage, whatever. There's always portions that you won't be able to graze or you won't be able to plough or whatever. So it's a crop, the same as any other farm enterprise, so you're going to have a return after it. You know, timber prices are at an all-time high now, so I mean that's beneficial, of course, but it's very much a long haul. People have to have faith in it and try and just hope for the best, I suppose, with it. But I don't think anybody ever regrets planting trees.
Professor Gary Lanigan is head of greenhouse gas research at Teagasc, and he told us that measuring carbon in forestry is easy, but it gets difficult when you get down to the soil level.
You talk about measuring carbon sequestration. It's very easy to do in forests because all you do is measure the standing biomass, but when it comes to measuring what's in the soil, it's actually very, very difficult. And if you want me to give you an analogy of that, it's like me telling you that I have a tap-on drip in a swimming pool, right? And the only way that you can measure how much water is going in is by measuring the height difference of water in the swimming pool over time. So what you have, it's exactly the same thing. So you've got a very large background of soil carbon and you're measuring a very small dripping input into it. So measuring it's very, very difficult.
Only a small amount of carbon taken up by plants ends up in the soil, and farmers like Nicholas appreciate the role of carbon and the important role that their forests play. But questions remain.
Everybody is now also talking about the sequestration with carbon, so it's obviously going to be a help to my farm here that's on it, but it's unquantifiable. I mean, I don't know what I'm going to get for that, or I don't know what is going to return me anything. Yeah. So I'd like some clarity on that from somebody.
There are two issues. There's how much carbon you have in your soil, and there's how much carbon is accumulating every year. So if we take two contrasting examples, we take a grassland on mineral soil, okay, say a glaisol or a podsol. That's probably sequestering maybe about a tonne of carbon, half a tonne to a tonne of carbon per hectare per year. But you're trying to measure that in a background of 300 or 400 tonnes of carbon. So it's difficult, but those mineral grasslands probably are sequestering carbon. On the other hand, you have a grassland on a peatland soil, and the carbon stocks in that soil isn't 300 or 400 tonnes of carbon, it's 3,000 or 4,000 tonnes of carbon, okay? And the problem with that is that carbon, then oxygen is introduced into the system and it all comes out. So while our mineral grasslands are sequestering maybe somewhere about half a tonne of carbon per hectare per year, our peatlands are emitting 20 tonnes of CO2 per hectare per year on average.
Okay. So the soil, the fundamental of all agriculture, the different types of soils are really important.
Very, very important. So
okay.
If I take, for example, a free draining brown earth, which most of our tillage systems would be on, they would be, in terms of, if you think of a carbon sink literally as a sink, it's like a wash hand basin. Typically about 80 to 100 tonnes of carbon per hectare, okay? And the reason it holds on to very little carbon is because the soil is very sandy, okay? And carbon needs to latch on to silt or clay particles because they have opposite electrical charges, okay? So it literally sticks to it. So for clayey soils like glazols, podzols, grey-brown podzols, they hold much, much more carbon. That's much more like a bath. And then the peat soil is more like a very large swimming pool.
Okay.
Yeah.
Anthony Browne and Liam Byrne are members of the Irish Wood Producers Group, and their concerns mirror those of farmers around the country.
First of all, what we're hearing most is what ownership of the carbon credits. And I suppose then after that, it's with the policies coming down and with methane gas from whatever, I suppose farmers are very concerned and what way stocking rates are going to go in the future.
The government said that they pay the carbons, they feel that, or pay the premiums on the trees that you grow. They feel that they own the carbons, but really it's the ground we own and that's where the carbons lie. And I feel that, be hobby horse with me, I think unless that we get paid for these carbons, forestry will die a slow death.
Who owns the carbon is important. But first, proper carbon markets have to be developed and a policy agreed on so that a proper return is made for all involved and a good price is achieved.
Whether it's the voluntary market they're moving into or whether it's the certified market, okay? The difference between one is the voluntary market is essentially a notional credit, whereas the certified market, you have to have your carbon credits certified by a certification body like Vera or the Carbon Trust, etc. And of course there's a transaction fee there. But the price of carbon is very different, okay? So on the voluntary market, I think it's 15 to 17 euros a tonne. On the certified market, it's over 50 euros a tonne.
Yeah, okay. So that idea of getting certified, then, Guy, what might that process look like?
Okay, so in terms of the vision, I think that the EU Commission have, that DG Klima have, is that it would be a functioning traded market, whether it would be simply a sectoral type approach where the credits would stay within agriculture or within agriculture, forestry and other land use, or whether it would be traded a free-for-all. Okay. So for example, Lufthansa, for example, could come in and buy the carbon credits in your forestry or in your peatland or whatever. And the problem that has that while you probably make more money, because of course if there's more people willing to buy the credits, the price will go up. The problem you have there is then the credits would leave the sector, but more so the credits would leave the country. So then it would become harder and harder to fulfill our national obligations. So there's a balance between the individual's, I suppose, the individual's interest in getting the best price for carbon and the sectoral interest in making sure the sector meets its it's agricultural greenhouse gas targets, and it's land use change targets.
As most farmers will tell you, markets are volatile places.
No, well, we were sugar beet growers here in 2006, Chris. So we were made redundant. Basically, it was a European decision. The sugar beet industry was closed down. We were compensated for 1 or 2 years profit margin on the crop, but that was it. You had to go off and do something else. So we were looking around for something at the time, and once again I was approached by a company that were involved with boiler sales, and they were looking for someone to do a wood chip supply for them. So that's how I got into it. It was maybe stumbled into whatever, but we're still going anyway, still at it.
Nicholas got into supplying wood chip when a boiler company approached him, and when his local producer group needed a depot for wood chip, he found himself well placed to get further involved in that market.
The group were looking for somebody to operate a depot as they were having some difficulties when they were chipping on site. So I offered my services to them, and we came up with an arrangement whereby the timber from the grower's site is brought here on the lorries. It's stacked on our roadways, which are all around the farm here. They're cow tracks, but we just use them once either side to stack the timber, and there's a hardcore base underneath so the lorries don't get stuck. So then we have a drying period, then can take from 3 to 4 to 6 months or longer, and then a chipping contractor comes in and he chips the timber for us, and then we use outside contractors again then to deliver the chip to our customers, mostly Dunne. So that's the bit that I do. I sort of, once the chipping is organised, then we just organise the logistics of getting it in chip, the logs into chip, and then onto a lorry and away at the right moisture content.
The wood chip supply chain has now become an established income stream for farmers, but the carbon markets have to be developed so there's integrity in the system and the bodies responsible can stand over the carbon measurements.
For agricultural soil carbon, it's a much more difficult process in terms of what we call MRV, measurement, reporting and verification. And at the moment what we're doing is we're distributing 32 CO2 flux towers around the country in order to measure at the field scale the carbon balance of grasslands, croplands, peatlands, and we're combining those with actual soil measurements. So we have 110 signpost farms across the country. We've soil sampled every field in every one of those 110 farms, and we will then go around in about 5 years' time and do a resample. And so between both of those and then models, which we can mathematically model what's going on in terms of soil carbon, and mathematically recreate what's going on in the ecosystem. So we utilise the measurements that we make to validate the models that we have, and ultimately it's the models then that end up in the inventory.
While creating new forests is the easiest way to capture more carbon on your land, farmers also need to be aware of other gases being emitted into the atmosphere from their activities.
So we have two main greenhouse gases in agriculture, and they are not CO2. Okay, so they are methane and nitrous oxide. Methane comes from what we call enteric fermentation, i.e. animals belching, and also from manure management. And nitrous oxide comes from animals defecating, urinating on the field, and the spreading of mineral fertilizer. So in fact, when anybody asks what I do, in the most part it's research on animals belching, urinating and defecating. So that's 90% of what I do. But they're the main sources of emissions. 60% of our emissions are methane from enteric fermentation. Another 10% is methane from manure management, and the remaining 30% or so is nitrous oxide emissions.
While new feed supplements are being developed that aim to reduce the production of methane in the digestive tracts of animals, there are steps that farmers can take right now to address some of these issues.
One bit of the greenhouse gas budget that you can affect very quickly is the nitrous oxide part. And that's built around three things. Reducing the amount of chemical N, which at the moment is probably an easy sell because of the price of it. So put in legumes. Get your pH right. If you do nothing else, get your pH right, because if you have a good pH, you'll have good nutrient availability, and you need less mineral fertilizer. We reckon for every pH unit that you get nearer to 7, that you require about 70 kilos of nitrogen less per year over a 3-year period. You know, so that's the first thing to get right. Then get some legumes into the sward. So clover will fix between 80 and 120 kilos of nitrogen per hectare. And then if you have to use mineral fertilizer, and you're on, particularly if you're on heavy soils, move from calcium ammonium nitrate to protected urea, because the N2O emissions from ammonium nitrate is 4 times that of people can do. And then there's other stuff as well that they're doing again, and it has an added benefit that it reduces nitrous oxide but also reduces ammonia, and that's the use of low emission slurry spreading, again replacing straight urea with protected urea, and they're the 2 big levers that will reduce our ammonia emissions.
No, so quite an interesting, a bit more than an introduction, I would say, to the area of carbon and forestry, and we expanded out a little bit into the broader area of agriculture at the end. Probably maybe to tease that out a little bit more and maybe focus on the forestry element of carbon in particular, we're now going to get Dr. David Stiles to make his presentation. David is from the School of Engineering in the University of Limerick, and he's going to talk for a little bit about the long-term benefits of mixed forest on carbon sequestration. So David, over to you.
Thanks very much, Andy. And firstly, I'll just try and get the technology right and share my screen. So I'm hoping that you were all able to see the screen okay?
Yep, that's perfect, David. Thank you.
Great stuff. I'll just get rid of this box and put it into presentation mode. So thanks for the introduction. It's great to follow Gary, who's given a very comprehensive overview of the balance of greenhouse gases and the difficulties of measuring carbon in soils in particular. So here I'd like to just present some results relating to forestry from a project that we've done that's almost finished now, funded by the EPA and Department of Agriculture, where we've looked at how we get to climate neutrality in Ireland's land and agriculture sector. And forestry has really come out strongly as one of the big levers that we can pull actually to try and get to climate neutrality. So it's trying to show you some of the logic and some of the numbers that make climate neutrality so challenging and that make forestry such an integral part of achieving the balance. So we look at firstly, how do we define climate neutrality? We'll look at what achieving a balance in Ireland could look like by 2050. And then we'll think about how we might sustain that balance beyond 2050 and draw a few conclusions. So firstly, when we started the project, we thought it would be very simple to define neutrality. We've got the way that we account for carbon in national inventory reports now, and that's based on the so-called GWP 100 approach, where we relate all the gases to CO2 equivalents. And we've got the 3 main gases Gary talked about: methane, nitrous oxide, and CO2. We relate every kilogram of N2O to CO2 by multiplying by 265, and every kilogram of methane to CO2 by multiplying somewhere between 25 and 32, depending on the method. And then we add them to the CO2 emissions. But that seems to be changing. There's a changing understanding of the role of methane, which some of you might be familiar with. And that suggests we're going down towards a road of having a separate target for methane. And to simplify things, that's got its own challenges, and we're going to have to reduce methane. But to simplify things, we'll talk especially today about carbon dioxide and nitrous oxide, because we'll definitely need to achieve at least a balance between those emissions over time. And the challenge of doing that is that every kilogram of nitrous oxide that we emit needs us to remove from the atmosphere 265 kilograms of CO2 to neutralize, because it's so much more potent as a greenhouse gas. So that's why we actually need to achieve very large CO2 emission removals in the land sector to offset emissions of N2O in this sector, and that's what I'll show you in a few minutes. And we're not starting off from a good place in Ireland, because we've got large areas of drained organic soils. We've got some grassland carbon sink, about 2 million tonnes per year that Gary was talking about, We've got maybe over 10 million tonnes a year of CO2 coming off drained organic soils. We've also got the emissions of methane from animals, enteric fermentation, from manure management. We've got soil N inputs, which drive soil nitrous oxide. So, and then we've got the forestry, the existing forestry sink, which is weakening through time because of the age profile of the stands and because of new emission factors for organic soils where a lot of forestry was planted in the past. And so that means that the forestry sector is potentially moving towards being a source rather than a sink in the near term, which is a big problem because then we're adding it on to all these other emissions. And we simply don't have the balance. When we talk about climate neutrality, we have to get these emissions in balance. And you can see we're way out of balance at the moment. We've got a net emission of about 25 million tonnes of CO2 equivalent from the land sector and agriculture sector. So the real challenge is, how do we get to zero? We've got 30 years if we take our 2050 commitment seriously under the Paris Agreement to get to zero net emissions in the land sector. And so that involves doing things very differently. We obviously have to change a lot about what we do in order to get to zero. And there aren't many levers we can pull. So I think, as Gary showed, you've got various sources of emissions from animals, and we can think about them as the agriculture sector emissions from animals and fertilizers, essentially, the methane and the N2O. We've got all our emissions from organic soils, from draining those organic soils. And then we've got our forestry offsets. And so this is just some very simple indicative numbers, if you like, for what climate neutrality could look like, looking at these main emission sources and the sinks. And so what we need to do is achieve a balance. That's just a mathematical zero-sum game, essentially, that we need to manage if we want to get to climate neutrality. So if we just look at CO2 and N2O, we're excluding the methane now, which will need to be treated separately, then we can drive down emissions in the agriculture sector by anywhere between 25 and 75% by 2050, depending on what we do with animal numbers, with mitigation technologies. We can re-wet a small area of organic soils, or we can re-wet a large area of organic soils, depending on our ambition doing those things, and we can have any combination in between. But the less we do to drive down emissions from organic soils and agriculture, the more heavy lifting that forestry needs to do to offset those emissions. So we need massive areas of forestry, 1 million hectares of new forestry by 2050 if we don't do much, if we only reduce our agriculture and organic soil emissions by 25%. If we're much more ambitious and somehow manage to reduce our agriculture and organic soil emissions by 75% by 2050, then we need a much smaller area of new forestry over that time, 0.3 to 0.4 million hectares. And that's just a zero-sum game. It's very simple, but it's quite important that we engage with that we don't have many levers to pull to get to net zero, and it's going to involve a combination of big emission reductions and big emissions removals. And we don't have many options for removals. Even when we wet organic soils, we don't really get much of a carbon sink. The best we achieve is we turn off those emissions to a large extent. We end up with some methane emissions, but overall are very close to zero balance for emissions in those re-wetted organic soils. So forestry is one of the big scalable options that we have, new forestry, that is, afforestation. And so we are going to have to be very ambitious with our forestry planting if we want to get to net zero. And basically, the more ambitious we are with forestry, the more headroom there is for continued agricultural activities to maintain emissions from more production of meat and milk. If we don't do much with forestry, we don't have much headroom, and there might come a time where we simply have to get rid of a lot of livestock in order to get to that net zero target. So the fate of agriculture and forestry are very highly intertwined. They're not in competition with each other. I think to be successful for net zero, we need to work together and have a lot more activity on mitigation in the agriculture sector and planting more trees for removals in the ag sector, in the forestry sector. And you're all familiar with this, those of you involved with forestry. It takes some time for the trees to start sequestering carbon. So if we start planting soon, we're not going to really get much, start generating many credits for some decades. It takes some time to roll out a planting program, to plant more and more area year on year. And it takes some time for those trees that are planted to really start growing at their peak yields and therefore taking out CO2 at their peak capacity. So we really need to start planting soon if we're serious about the 2050 target. And with the numbers I was showing you in the previous slides, to have a realistic chance of getting to net zero based on those numbers, we're talking about very high planting rates of 13 to 40,000 hectares per year, which is obviously way beyond what's in the current ambition. But I believe that the maximum planting rate in Ireland in the early 90s was around 22,000 hectares per year. So it's not unachievable, but it is something that is going to have to be engaged with if we're serious about getting to climate neutrality within our national boundaries. And something to note on that, we won't do much for our 2030 targets. There's been a lot of emphasis on the 2030 targets recently, and they're obviously very important. But even if we take a lot of action now, it's really action that's going to contribute to 2050 rather than the 2030 targets. The question then, of course, we could plant large areas of trees, but what happens after 2050 if we wet organic soils and if we plant large areas of forestry? Firstly, we're going to need quite a big area of diversification, which is potentially going to have implications. It might mean less profitable livestock production converts to forestry and to other activities, and there might be other demands for bioenergy crops to feed bio-based energy or bio-based materials in the future. But then if we stop planting in 2050, there is a risk, of course, that we simply delay the carbon cliff that we're very conscious of coming up because of the current aging of forest stands and the lack of planting in the recent past. So is there anything that can be done to avoid that? And of course, if we plant conservation forestry, we're leaving those trees in the ground much longer, they grow more slowly, so we have a longer sink, but a more gradual sink. If we plant commercial fast-growing species like Sitka spruce, the sink is much faster, but potentially we have a carbon cliff coming up towards the end of the century if we start planting in the 2050s. However, there's lots of options for what we do with wood. And just an example down on the right-hand side, you can see a kind of cascading chain of the types of uses we get out of wood and the product breakout. And we can start thinking about what's going to happen to that wood in future, because if we have a big forestry planting program starting going on over the next few decades, that wood isn't going to be harvested for another 40 or 50 years from now. So just to summarize some work that we've looked at recently, which has been published last year, we looked at, in the UK context, what would happen if you had an ambitious planting program, 30,000 hectares per year, up to 2050, and if you took a 100-year view to say what's the total mitigation over that time. So of course you start off with very strong carbon sequestration in the actual land sector itself, the trees that are growing, and as Gary said, we can measure them and estimate that growth very easily, and that can be calculated just based on growth rates of trees, and of course at peak yields of 20 cubic meter per hectare per year. Forest, we can calculate the amount of carbon that's sequestered in the wood and the leaves and the branches and the litter, etc. And it works out to be potentially over 20 tons of CO2 per hectare per year at peak growth. So we can calculate that, and that's a big, that gives us a lot of mitigation, if you like, a lot of sequestration from the 2020s when we start planting up to the 2070s. But then we start harvesting a lot of that wood, and so we start to reduce that sink because we're taking carbon out of that forest. So that sink weakens, but we start building up our harvested wood product carbon pool, and then we start potentially using that wood for things that we didn't use it for before. We might use more wood in buildings. We can start displacing concrete and maybe some steel, and that can give us quite big credits actually if we start reducing our concrete production, because we're able to use more wood, cross-laminated timber, glulam, etc. Potentially, we've got the option of cascading use, where we can use those wood for a few different things over time, and that's something we'll look at in a minute. But to come back to the actual land use carbon, it's important to note here, with some modelling we've done, you can see very clearly that if you reduce livestock, you'll certainly reduce your emissions, but you're never going to get anywhere near to net zero. If you add some rewetting in there, some ambitious rewetting of organic soils, you'll certainly get a bit closer to zero, maybe halfway towards net zero, climate neutrality. It's trees that really bring you all the way down to net zero, because without those removals, we're never going to get to a balance in the agriculture sector, and that's just something I've shown there. So as we lose that carbon in the land sector, it can go into other products, which keeps it locked out of the atmosphere a bit longer, quite a long time. If we're talking about good quality sawn wood for maybe 20 or 30% of the output from the forests, maybe 45 to 70 years, 35 to 60 years for panel boards, shorter time for cardboard and packaging. Potentially, we've got demand for low-grade wood in the future from bio-based materials. We know we've got a big problem with plastics, for example. There's a move to making plastic from other materials and using cellulose and other ways to produce bioplastics. So potentially, we could be feeding into those bio-based value chains. We've got potentially big substitution effects, which I mentioned a minute ago in green, where we can replace concrete or steel or other high-impact materials in the downstream sector. And finally, either directly after harvest, say in 40 years' time from new trees, or in 80 years' time or 100 years' time from wood that's been gone through a growth cycle and then gone into a building, and then at the end of life that building comes out, we can use that wood for bioenergy. And the attraction of forestry linked with bioenergy generation is that we're keeping the carbon locked up for quite a long time in the growing trees and then potentially in products. And that gives us time to get the technology right to keep the carbon locked up much longer. So you might have heard of bioenergy, carbon capture and storage. It's an unproven technology commercially, but technically it is proven. We can basically scrub out the CO2 from the exhaust gas of when we're burning bioenergy for energy, biomass for energy generation. We can put that into amine solutions, and then we can pump those solutions back down into oil wells or gas wells that we extracted oil and gas from. It's the kind of reverse logistics of the oil and gas industry, which sounds a bit perverse and a bit crazy that we'd be paying money to put the CO2 back down where we got it from originally. But the big attraction of doing that with bioenergy is that it acts as a net sink of CO2 from the atmosphere, a long-term sink, because we're using the trees or the biomass to take the CO2 out of the atmosphere, and then we're locking that CO2 away in geological storage for a long time. And crazy though it seems that this is one of our only options long-term globally to really get to stabilize our climate, to get to net zero. And so many of the scenarios that the IPCC have undertaken to look at what climate stabilization looks like globally are quite heavily reliant on this bioenergy carbon capture and storage technology. And the advantage of trees is it buys you a lot of time to get that technology to work. And so thinking about those options for future wood use, you can end up really building up a very compelling picture of a really centrally important role for wood delivering long-term climate mitigation in a way that very few other options can. And it's not, we need to throw all the options that we have technologically to achieve climate neutrality, but it does seem there's a fundamentally important role for trees to play, and in particular commercial forestry to play in that. And just to emphasize that, looking over the 100-year time period in the work that was done in the UK, we can see that the green bars are the terrestrial carbon storage on land. But over 100 years and two harvest cycles, we end up mitigating quite a lot more carbon through product displacements, fossil fuel displacement, concrete substitution, and carbon capture and storage long term. This is a hierarchical chain where we use a lot of the wood for high value products. And then this is a bioenergy chain where a bigger share of the wood goes to bioenergy directly. So we have a slightly different profile with more carbon capture and storage here. But you can see that the magnitude of savings from the downstream effects is actually bigger than the actual sequestration in the forest itself, if we take a 100-year view and if we're able to implement some of these technologies for wood use into the future. So these are for commercial forests. And if, of course, we could just leave the trees in the ground, if we find the technology doesn't work, we could leave those trees in the ground and they will continue sequestering for some time. And with a commercial Sitka spruce, you'd actually end up with a similar amount of mitigation if you simply left those trees in the ground for a very long time. Economically, that wouldn't be an attractive thing to do unless you were paid the carbon for it. But you can see that you end up with much more mitigation from these commercial forests than you do from the semi-natural or the mixed forests. And that's not to say we don't need to plant large areas of these forests, which have a different longer-term role in mitigation and a very important role in biodiversity and ecosystem services delivery. But it's just to say that from a purely climate neutrality and carbon offset perspective, commercial forests could be very effective long-term. Perhaps what was a bit surprising is with sensitivity analysis, different uses of wood, bioenergy heavy versus product heavy, and harvesting here or not harvesting with the same Sitka spruce stands didn't actually have as big an effect as we thought on the net mitigation. The really important factor, as you might imagine, is simply the rate of growth of the trees, because that's what's drawing down the carbon in the first place, whether it's left in the ground or whether it's used to offset other products by harvesting it and using it downstream. So the current choices now are basically, we've got choices about how much do we plant, where do we plant, and obviously there are rules about trying to avoid things like mistakes in the past, like planting on organic soils, for example. But how we plant and the types of tree we plant now is going to have a big influence on how we use the wood in the future and what kind of longevity of mitigation we're going to achieve and what kind of downstream economic activity we're going to sustain with that planting. So in conclusion, just looking from a carbon or climate neutrality perspective, we know we're going to need hundreds of thousands of hectares of afforestation over the next 30 years. It just seems impossible to get to climate neutrality without that. And that's actually coming at us very quickly with the timescales we're talking about with forestry. 30 years isn't a long time. We need to start planting very soon to get those credits happening in time to deliver neutrality by 2050. And when we think about future costs of CO2, when economists talk about costs in the hundreds of euros per ton of CO2, the value of that sequestration that's offered by every hectare of forest actually becomes huge, thousands of euros per hectare. And so those are real potential values to the state in the future, which otherwise could be liable for very heavy fines or to have to buy expensive carbon credits on the international market to compensate for not being able to achieve territorial neutrality. So from a state kind of national economic perspective, it would seem sensible to start thinking about spending some serious money now to avoid huge expenditure in the future, to help generate incentives for farmers to plant trees now to avoid these future CO2 costs. And of course, it's not just about carbon. There are lots of other benefits that we can get if we plant the right trees in the right places and get a mix of trees that also deliver biodiversity. There'll be some trade-offs between carbon maximization and biodiversity delivery and other ecosystem services, but those are things that will have to be thought about with some land use planning. And we also have the idea that such planting and achieving climate neutrality is actually integral. It's not a threat to the agriculture sector. It's integral to the future success of the agriculture sector, because part of the success of Ireland at the moment has been able to export meat and milk with a comparatively low environmental footprint and having a good sustainability reputation. And that will be completely lost if Ireland is not able to achieve its Paris Agreement commitments. So I think thinking about it in terms of reputational risk for the country, for the agriculture sector, and a just transition for farmers in terms of generating new income and diversified income for farmers is the sensible way to look at it, rather than seeing trees as in conflict with animals. So essentially, we'll be increasing the climate neutral livestock allowance, if you like, by increasing the removals achieved in the sector by using forestry. And of course, there's opportunities because countries like Finland have a vibrant and forestry industry that develops or that supports a lot of downstream economic activity. There's a lot of opportunity to get more value from wood than we do today by investing in technologies like processing for cross-laminated timber or glulam or bioplastics in the future that might be sourced from wood-based products. And of course, if we plant the trees in the ground now, we have these opportunities in the future. If we don't plant the trees in the ground now, we simply won't have these opportunities in the future. So thinking about all these things in the round and how we manage our land to deliver a sustainable amount of milk and beef production and other bio-based products in a climate neutral way, it is going to require some multi-pronged coordinated policy to think about the development of those bio-based industries alongside the incentives to put the trees in the ground. And this is really a long-term public good question, and it maybe flies in the face of some of the market pressures, which are very much about short-term profit maximization. It's not to say it's not a long-term profitable strategy, but it does take leadership and vision, if you like, to establish the roots and the foundation of that future kind of economic success. So that's just some insights, perhaps quite optimistic, but the only way that we can see from what we've looked at of how we're going to get to climate neutrality in Ireland is to rely very heavily on the forestry sector as the only really scalable carbon removal technology that we have at the moment. So thanks very much for your attention. I'm not sure. Should I pass back to you now, Andy? I think you're on mute there, Andy.
Sorry, Andy, you're still on mute.
Sorry about that. I was struggling to get my screen back up here. Can you hear me now?
And Andy, thank you very much.
Okay. Yeah. Thanks, David. That was a very robust presentation, I would say, it's something that our policymakers and probably our policy implementers could do with maybe hearing more of, because there does seem to be a certain lack of maybe understanding and impetus there. I meant to say at the start, we have some questions coming in. I think if it's in order, we'll leave the questions. First of all, keep the questions on the Q&A. It's the only way to put them in. So type in your question, and at the end of the session, we will take all the questions together, if that's okay with the speakers. Next, now I want to move on to Dr. Kevin Black. Kevin works for and is the Director of Forest Environmental Research Services Limited, and he's going to talk maybe about the specifics of carbon and carbon trading and that aspect of the business. So over to you, Kevin.
Thank you, Andy, and thank you, Gary and David, for a good introduction to the topic. I've been asked to cover something slightly different, and glad to see it's a question asked by Liam Byrne in the movie that we watched. So I'm going to talk about the voluntary carbon market and the mechanisms and how we get there and what's in it for farmers. Now, it's a massive topic, so 20 minutes isn't much, but I hope I could at least touch on it and give you an idea on what the taste is. So I assume everybody could hear me and could see the screen. If not, please let me know. So Kevin, what I want to talk, yes?
Sorry, Kevin, we can hear you, but we can't see your screen.
Thank you.
We better get it right. So we want to be able to see your presentation.
How's that now?
That's brilliant. Thank you, Kevin.
Pleasure. Right. So what I want to just talk about is briefly touch on the policy and drivers. I think David covered them very well. But just remember, there are two distinct markets, and to put the record straight, it's the compliance market and the voluntary market. Those are them, and I'll touch on them a little bit later. I'll just go back to the basic concepts, which I don't really have to do because David covered that so well, but I'll spend a bit of time about the voluntary trading schemes, what the mechanisms are, the pathways, and I'll give you some example of existing afforestation projects. And I just wish people would start talking about forest management, because there's also a massive potential there. People don't consider it. And in the short term, it's my view that it's got a larger potential in afforestation if you could implement it. I also got asked to talk about the carbon calculator. There's one on our website. There's also one for Teagasc. Seeing I'm not from Teagasc, I'll just present the one we have on our website, but it's essentially developed using the same protocols and methods. So I'm not going to get into the technicalities of measuring carbon and modeling. This is built up on our experience over the last 22 years. So I'm just talking about the voluntary trading market. The values I come up with are based on the technical capacity we've developed over the last 20 years. So we all know that afforestation has got a massive contribution to the current EU effort sharing agreement, but also its potential in the future is very large if we could scale up, as David mentioned. But it's highly dependent on afforestation rates. And the figure on the top right shows future afforestation sinks under different afforestation scenarios. The key issue is if we keep going on the trajectory that we are at 2,500 hectares a year, even our afforestation categories are going to start becoming emission. So there's something to do. And I think David covered all the aspects there quite well. I don't think I need to dwell on that any further, but I mean, we need more afforestation, and currently the policy that's out there isn't driving it. If you just look at the license application procedure and you look at the incentive for afforestation, obviously it's not. So does the voluntary market create a mechanism by which you could incentivize for it? The other one is the current management of the state, and this is what people don't want to talk about. Since 1990, the managed forest estate, which was primarily culture land until recently, so these will be forest land that hasn't been afforested in the last 30 years. In 1990, it was a net removal of about 3.5 million tons. It's now sitting at a net emission just over zero. So, and as more and more privately owned forest lands start going into this category, we know from the all roundwood forecast that we get a doubling in harvest, particularly from the private sector. So our existing forest is going to become a massive emission of about 4.5 million tons. So I've put my video off because of my narrow bandwidth. So I don't think you need to see me. You could just see the slides. I've got a request to see me, but I'll just keep going. So the two major policy drivers really are afforestation and forest management, and there's massive potential in both. But you've got to look at current forest management, and we've got to start doing something about this emission trend. And I don't think this is included in the current neutrality estimates that David was talking about. So it's something we should start thinking about. Now, coming back to future EU policy, there's clear directive under the Fit for 55 package, where Ireland has to reduce their current land use sector emissions. The current value is at about 3.74 based on the 2021 inventory, but we have to reduce this. It's currently at 7.8 million tons. We have to reduce it to 3.7. The forestry trends are going the opposite way, so we have to start doing something about it. I mentioned something about the grant incentives, and does the voluntary scheme do this? But the EU farming strategy during 2024 includes voluntary trading scheme contributions to be included in mitigation actions. So the EU is signaling some kind of EU-based voluntary carbon trading scheme, not just for afforestation, but for other land use activities like re-wetting. So they're signaling some kind of carbon payment to landowners that could be put in, that could contribute towards the overall Fit for 55 ambition. The same for forest management, re-wetting. But one of the things I'm going to touch on a little bit later is there's a need for clarity on compliance of registry adjustments to avoid double accounting. Now, I know this sounds like a lot, but a lot of people get confused between ownership of carbon and double accounting, and I'll try and clarify this in a slide later on. I think David's touched on this. I'm only going to talk about two components. I'm not going to talk about product substitution, because in reality, in the compliance market, product substitution goes off on the energy or the manufacturing sector, which is not part of the agricultural land use sector, but harvested wood products and forest pools do. With regards to voluntary market, there's an added complication of ownership. And this gets rather muddied when you look at harvested wood products and product substitution, because timber mills and downstream producers could start claiming ownership of the project. So you can't really claim ownership. But when it comes to the forest, I think it's quite clear, and there was a signal from the minister and a clarification in one of the farmers' journals earlier this year that it's not an only ownership issue, but a carbon registry issue. And just some concepts, just very quickly. And I think this has been alluded to a little bit earlier, that afforestation is a once-off mitigation action. So it's not permanent, it just buys us time. The two graphs there show a Sitka spruce yield class 16 and an oak yield class 6. And as David clearly showed, if you go for more productive species, you get a higher carbon sequestration in the short term. but it's a long-term lower net removal. In contrast, if you look at something like oak, it takes very long to accumulate carbon, but there's a higher carbon storage in the long term. And in the voluntary trading scheme, I'll keep on referring to this thing called the cap, and this is essentially the once-off carbon sequestration potential due to an afforestation project. So if you look at the curve, where the dotted line intersects the blue wavy line, that's where your maximum occurs in perpetuity. It also means you have to continue exactly the same management practice to ensure that you don't lose the carbon that you claimed earlier. And this is a thing called permanence, which I'll touch on. So the cap value is quite important when you look at afforestation projects. I'm just coming back to peatlands again, because in essence, any voluntary carbon standard doesn't consider peat or organic soils at all because of the risk and the high emissions coming from peatlands. So if you own a peatland forest, there's a problem in relation to access to the voluntary carbon market. And this is because afforested peatlands become a net removal for the first rotation, but the minute you start harvesting, the massive harvested loss from the soils and the dead organic matter and the continuing emissions from peatland soils result in a decline in sink. And eventually by the second or third rotation, depending on hill class, your forest is becoming a net sink. So it's not a good strategy and it's not a route to the voluntary market. We've got to talk about mineral soils only. So just very briefly, the concept of the voluntary carbon market, and just to clarify the difference between voluntary and compliance, the compliance market is an international binding agreement where there's trading done on an international registry like the emissions trading scheme. And countries that don't meet their target could buy the credits on these schemes to meet their targets. Obviously, this means nothing to the landowner, and the only way the landowner could access carbon revenue is through the voluntary market, either in offsetting or there's a new thing called insetting, which I won't go into today. But one of the things about the voluntary market, it applies to all activities, whether it's energy, wind farms. It is in a report based on the state of the voluntary carbon market from 2005 to 2015, EU voluntary buyers purchased about 16.1 million tons of CO2 from renewable energy and forestry projects, but nearly all of these originated outside Europe, and nearly all of these were from renewable projects because of the cost of forestry projects being so high in European countries. The cost abatement curve for renewable energy is sometimes much lower than that for forestry projects. So it's quite expensive to invest in forestry projects for carbon unless you're in the third world. One of the other barriers to this is the high cost of establishment relative to the third world. And what Gary referred to earlier is the high monitoring, verification and reporting costs in developed countries. So it costs you to put it onto the market, and the more you move to develop economies, the more expensive it is. There's also another issue around double accounting of voluntary credits on the compliance market. So if something is sold in the voluntary market, you can't then go and trade it again on the compliance market. And this is the beef that the state has with their voluntary carbon mechanism, because they don't want that to be taken off their compliance credit. It's not an ownership issue. And that has been clarified. So in any voluntary carbon project, the difference is that it's a project and it doesn't represent a national forest estate. Any owner could set up a project with a defined area. And what you do is you develop the project, you write a design document which gives you all the estimates of your removals that you think will happen and your compliance to the rules. This gets validated through an accredited agency. And once the emissions occur, this is a very important thing, only after the removals occur and they're measured and verified, do they issue the credits, which then could be traded through a registry to agents or a trader, and buyers could buy it. Once buyers bought it, it's retired. So the important thing is there's no double accounting. It's traded once, bought one, and then it's retired. So the idea about a verified credit is that it has to adhere to strict standards to make it viable, right? So it's essentially, the analogy is if I produce engineering parts, I have to adhere to ISO standard to make sure that my part is compliant and people get what they promise. It's the same for carbon. So there's no use trying to sell carbon on a system. It's got no value. You're selling hot air if it's not compliant with some kind of third-party verification. And there is an ISO standard called IEC 17029, which most voluntary carbon standards are adhered to. I'll come back to ownership issues in a minute. So this is a very important slide, because what a lot of people don't realize is the criteria for voluntary trading schemes. And these are the 6 most important ones which you have to adhere to. So it's not a simple system. And there's a risk of reversal. So the first is eligibility. And this comes back to the ownership issue. So this is what's referred to in the trade or legal term called offset title. So you have to demonstrate undisputed proof of offset title, which means that you have to show that you're the owner. If you go into practice with the economic operator that runs a project on your behalf, you could have a contractual agreement that lists this and shows that there's undisputable proof of ownership or consent to trade on your behalf. So this is very important, and I don't think the state is right by saying that they have an ownership claim. It's the double accounting claim, which I'll come to in a minute, because if you own, in my view, if you own the soil on your forest and the timber on your forest, and you could sell the timber, you could surely sell the carbon, because they're made of the same thing. So I don't see any legal premises that there's state ownership just because they've sponsored it through grant aid. They've also sponsored it for development of the forestry industry and development of the timber market. They're not claiming ownership of that. So it's not an offset title, but you have to show that, or have some kind of contractual showing that your project has got offset title. As I mentioned earlier, organic soils are excluded. And there are the methodologies used under each standard cover specific activities, either afforestation, forest management, re-wetting, and the methods have to be complied to strictly for you to get your verified credits. So eligibility is the first thing. There's a little bit more to it than that, but that's just the basic idea. Additionality is a very important concept, because as the atmosphere sees it, if we just continue on a business as usual trajectory, you make no difference. It has to be an additional activity. So what we're saying is the carbon sequestered by a project is or will be additional to what would have occurred in the absence of the project. And this is a very important thing. So what it means in the terms of afforestation, if you have an existing afforested land, you can't register it for an afforestation standard because it's already afforested. There are some standards that allow 1 to 5 years time for after initial establishment for eligibility criteria and additionality, but that's the general rule. So if you have an existing forest, the only way to have an additional activity is to change the management trajectory. You have to show it's additional, or you're breaking some kind of a barrier that results in real change to the removal of CO2 by the atmosphere. So in essence, the voluntary market is much more stringent on the rules than the compliance market. Because it's traded on the open market, and there are strict principles that are adhered to. Some standards have this financial additionality, which means that the project wouldn't be additional if the carbon finance didn't make it economically viable. So in some cases, like highly productive Sitka spruce stands with grant aid, it's very hard to argue that the internalized rate of return is not economically viable without carbon tax, so without carbon trading revenues. So some standards consider that too. Permanence is a very important thing, and that's why I mentioned the cap a little bit earlier. So essentially what they try and do, any standard will remove the risk of reversal, either due to clearfell or deforestation. And what they generally do is they withhold a credit issuance unit as a buffer in their reserve in case something like that happens. And there's also a contractual agreement with the project owner to do some kind of payback if there's a reversal. So there's a risk there that you're contractually obliged to, illegally obliged to. And materiality really relates to the verification of those carbon credits. So if I plant a unit of forest land now, as you know, there's very little I could claim for the first 5 to 15 years until I get measurable carbon credits, which are then verified and sold. You can't sell these before the forest has reached that stage where it's captured carbon. It's got to be real. So coming back to the double accounting issue, so what happens in the compliance market, national credits are registered on the emissions trading scheme. But if I register a voluntary carbon project, I have to get permission from the registry, which is the EPA in this case, to adjust the registry. And there's no current mechanism, and this is where we need clarity from the EU. In my view, this is the barrier of the voluntary carbon market in Ireland. We could develop it, but we have to come over this double accounting issue. So the state essentially has to take those accountable amounts of carbon claimed on the voluntary market off the compliance market to make sure that you don't sell the same unit of carbon twice. Another consideration is leakage, which is subtracted from your emission removals or your removals. And leakage, for example, is if there's intensification of agriculture due to placement of agricultural activity. So you have more livestock emissions because of forestry activity, or market shift leakage, which is quite negligible in the Irish context, but it could be because you have reducing harvest. It could affect market price and it results in deforestation elsewhere, and this has to be considered. So it's quite complex, but those are the basic rules. When it comes to methodologies, the basic concept, whether it's the voluntary carbon scheme, that's VERA, the American Carbon Registry, or the Woodland Carbon Code, is that you register a forestation project, and you only get your removals after it starts accumulating. And once you reach this thing, I'll talk about the cap, that is the maximum you can claim, even if the project period extends beyond the cap. And that's done to ensure permanence. So the baseline in this case is the land use greenhouse gas profile without forestry, which is the red line. So that might just be, say, for example, a crop. In that example, your baseline might be a little bit higher if you had livestock on it, but then of course you have to show that you have no grazing shift leakage. So that's an example. So the difference really on your claimable amount is the difference between the blue and the dotted blue line and the red line in an afforestation project. Forest management, on the other hand, we have an existing forest. You have to change the way you manage the forest, for example, to go through extended rotation, continuous cover, reduced harvest, etc. And there the baseline is the red, which would have been the current management practice, such as shortened rotations, economic rotations. And if you extend the rotation, the difference between the blue and the red line is the project that you get. But leakage is quite difficult to demonstrate in a forest management situation because you're delaying harvest. So this market shift leakage I was talking about becomes a problem. So what I'm going to talk you through now is the typical process of going through a voluntary carbon project. Now, they're all the same. I'm just using one we're developing in Ireland called the Deforestation Carbon Standard. There's been a delay in getting it over the line because of this issue of double accounting and some funding issues to get the registry and the standards set up. But conceptually, it's been set up with commercial partners. So essentially, you have the forest. You have a area you want to afforest in case of afforestation. The project owner or the landowner get together and they decide that they are going to apply for a afforestation license. They check the eligibility criteria, they select the methodology, and they calculate the carbon, which is set out in the standard methodology. They then write what you register an account with the registry, and you write a project design document which outlines what you're going to deliver, what the adherence criteria are, how you're going to monitor and verify it. So it's all documented. And this is a legally binding document that you sign with the standard. And what they do is they validate your project and say, are you registered now? And they issue you what they call a pending issuance unit, which tells you your potential carbon units coming out of it. I'll give an example of what the numbers are in a minute. And then from year 5 onwards, depending on the lifetime of the project, you go through the monitoring and verification, where your forest is inventoried and measured, and the carbon credits are calculated and verified by an independent third party. Once that's been verified, your carbon credits are certified, and they are issued subject to adjustments, and I'll come to the adjustments in a minute. So this is a typical example for an afforestation project, yield class 16 Sitka spruce. I think it was marginal thinning intensity, I can't remember. But so essentially what you do is you calculate your forest removal units, and an uncertainty adjustment is applied. So whatever the uncertainty is, they take it off. And this is a buffer around uncertainty because you're using a model in an anti-estimate of your carbon sequestration rate. Then they apply the cap, which reduces the potential further. Okay, you should note that the harvest emissions due to machine use, etc., is included in the forest emission removal, and that is also calculated. You then calculate your baseline, and depending on the size of your area and the criteria, but in this example, assume you've got the 0 baseline, and you assume you've got 0 leakage, just to make the example a little bit earlier and due to a lack of time. You also subtract your establishment emissions, so your fossil fuel emissions from establishment and materials. And then you apply what they call a withheld buffer unit to deal with permanence. So what you have is, starting about 380 tons of CO2 equivalents over the lifetime of a project, say 55 years, you end up with 195 after all these subtractions. Okay, and that is then validated. If an adjustment is applied, that's applied, and then that's credited. So you nearly ended up with a little over half of what you eventually started off with. And people just have to realize this. And here's the theoretical example. There's a lot of story about what the carbon price is. It's not 50 euro a ton. The voluntary carbon price currently is at 7 euros. It depends on the type of product being sold. The UK Woodland Carbon Code, I think, is at £20, but this is because it's backed by a government sorry, I've lost the word, a government guarantee. So let's assume you've got 10 euro per hectare, based on the example I gave you earlier, and say you have 10 hectares. Those are the kind of revenues you could expect from your carbon project over the lifetime of a project. That's your internalized rate of return, including your timber costs. And just remember that your monitoring and verification costs could be 20 to 30% of your CO2 value. In this example, I assume that there's a rent forgone cost and grant aid, and a standard timber revenues using the long-term standing prices. So there's an example, excluding it, including carbon revenues. So that's just a hypothetical example. It makes a difference. It's not going to change the scheme, but it's going to tip the scale. So there is a potential here, and there's definitely something in it. And this is just an example, please. This could vary from standard to standard, from site to site, depending on what your baseline is. So this is just an example, just to give you an idea on the figures and how they're derived. Excuse me. Just very quickly on the carbon calculator. This is just a calculator that excludes any of the voluntary carbon withheld units that I've talking about a little bit earlier, but it works the same as the Teagasc calculator, where you could go into our online system, select your grant category, your soil type, how many hectares you have, your timber prices if you want to do some discounted revenue, just indicative prices, and it spits out carbon sequestration values for the forest. So please feel free to go. The graph there just illustrates the difference between different categories and species. And I'm just again saying there's a difference between the short-term potential gain in very fast-growing species like Sitka compared to oak or native woodlands, which have a long-term higher cap, but they take longer to get there. So that'll just give you an idea on what the differences are for the different species, only for mineral soils in this case. Right, so in conclusion, look, the voluntary market's been there for the last 20 years. It's been operating in the third world for as long since this clean development mechanism, but it hasn't come to the developed world, particularly the forestry element of it, because of the cost of land, the registry adjustment issue, and the monitoring verification costs. Just bear in mind too that there are risks. But like any market, there's a risk, and farmers are very familiar with this. But be very aware of sink reversal and non-permanence. This is something you've got to really be careful about. Organic soils are bad news, so that's really excluded from all standards. And it's very clear that the economic returns are not going to be larger than timber revenue. So it's very unlikely that you could use a voluntary carbon scheme to counterbalance harvest revenue losses due to extended rotation. But it could be a case if the carbon price goes up, which if we don't meet neutrality, all indications that it will, that this depends on carbon price in the future. There are strict eligibility criteria. And as I mentioned earlier, we just need clarification from the EU on this adjustment to the registry before we could really develop the market on a local case like we have, like has happened for the UK Woodland Carbon Code. As you know, you can't trade Irish forestry projects on the Woodland Carbon Code because it's a separate jurisdiction. But you can now access, you can try and access other standards, but this registry requirement is the major barrier. I hope I've covered most of it, and I'm sorry I harped on for a bit long. Thank you very much, Andy.
Thanks, Kevin. Good lot of stuff there and food for thought. It is complicated, but it is kind of starting to mature into something that might be workable. But there are, as you say, there are ups and downs in it that people need to be aware of. Gary has joined us, I see. We have a few questions, which I know they've been coming and going there, and some of them have been answered. But we'll just run down through them now fairly quickly. I'm aware we're gone 15 minutes over time, so I don't want to take too much more time at this. First question, I think, Gary, if you're there, can we get the figures / metrics again? You mentioned the relationship between soil pH and nitrogen greenhouse gas reductions in the
Yeah. So for every 1 pH unit, you move your soil towards pH neutral, i.e. pH 7. You release about 70 kilos of nitrogen per hectare. So that's what we found in our research. So if you move, for example, from pH 5.5 to pH 6.5, which would be usual after liming, you're releasing about 70 kilos of nitrogen per hectare.
Okay, thanks, Gary. Just again, while you're on, and it's been a kind of a common theme during the evening. I saw the question did pop up. Somebody asked what was an organic soil, and as we all know, all soils have an organic component. So what is the threshold here that we're talking about? Has anyone any insight on that?
So the strict definition of an organic or a peat soil is that it has a minimum of 20% soil organic matter, and it's a minimum of 40 centimeters deep. So that's the threshold. Anything below that, we would call an organo-mineral soil. Essentially, the reason, and Kevin touched on it as well, the reason they're not recommended to be afforested is because when they're afforested, water table goes down, and it's similar if they're drained for agricultural purposes. So once they're drained, then you introduce oxygen in, decomposition begins, and you release a lot of CO2.
Okay, thanks, Gary, for that. See, John Sherlock has a question here. Softwood versus hardwood. I think both David and Kevin talked about the differences in carbon sequestration between softwoods and hardwood. So whichever of you guys would like to take that one. David, maybe.
Okay, thanks, Andy. So yeah, I think as Kevin said, clearly the rate of uptake is going to be slower with hardwoods. They're slower growing, denser, so it takes longer to take that CO2 up. So it really depends on what timescale you're talking about and where you draw your boundaries. Are you considering the downstream products or just the land itself? So I think as Kevin said, there's potential for more long-term carbon storage with hardwood species, but it takes a lot longer to get there versus less total carbon storage, but getting there more quickly with the softwoods. I don't know if Kevin's got more to add to that.
Kevin?
I think that's it.
Okay.
You've got to trade it off. What we haven't spoken about, there are also biodiversity markets developing. So I think there's a lot of room for native woodlands, broadleaf forests, because of their biodiversity value. Not that conifer forests don't have biodiversity value, but I'd say they're not as great. So that's a new hot topic. I mean, people start talking about biodiversity credits. When you add it all up, and it's not just about carbon sequestration, there's a lot more that we have to consider. So we have to look at it in that context. But David is right. Short-term conifer is a better strategy. This is the same strategy the UK Forest Research and Forest Commission have. So if you want short-term mitigation action, go for your productive conifer forests. If you want long-term, go for broadleaves.
Okay, thanks, Kevin. While you're on, Kevin, the next question here in the Q&A is specifically referred to you, and it is, I suppose, about the ownership issue of the credits. Maybe you might use the question as an opportunity to expand on that point. Maybe you did go through it.
Yeah, I did an article for Donald Magna in the Farmers Journal on this. And in the same article, I think the minister did a clarification at the same point. So people have been saying for the last 10 years that the ownership is the barrier for a carbon trading scheme. That's simply not true. It hasn't been legally challenged. And since the minister has now said it's not the issue, I don't think that's the barrier. The barrier is what we call double accounting and adjustment of the registry. So to ensure that you don't double account, so you can't sell the same unit of carbon twice, right? So if on the voluntary market, you sell a unit of carbon, the government has to take that unit of carbon off their compliance market. And this is what the issue is. Even if they wanted to, I'll leave it at that. Even if they wanted to, there's no mechanism under the EU trading scheme to do this. And this is the clarification that DG Climate and the European Commission has to come up with if they want a carbon farming strategy. So if anybody wants to lobby for some kind of movement, we have to go to the EU and get them to make some kind of guidance on how the registry will operate for both the compliance and voluntary market. Once you've done that and the standards are set, I have no doubt we'll have a voluntary trading scheme in Ireland.
Okay, thanks, Kevin. A namesake of my own, Colm Dunne. I think you've been there in answering that, Gary. Definition of peat soil, and we'll move on to the next one. Justin Good. Will there be carbon credit recognition given to existing woodlands of 20 to 30-year-old, 20, 30 years planted and under CCF? So that's asking, is there we talked about a baseline or a timeline, or essentially the credit being from now. Maybe Kevin, have you a comment on CCF?
Well, as I mentioned, I'll come back to CCF. If you have an existing forest, you have to change current practice on management. So we have to move away what the conventional management practice is. So we got to move away from shortened rotations of commercial, either to extend it to maximum annual increment, delay harvest, or there's no doubt that continuous cover offers climate change resilience, but unfortunately it's quite a young management principle in the UK and in Ireland, and maybe Switzerland, Germany, France might have real continuous cover forests. In Ireland, we are transforming to continuous cover. So the transformation process to continuous cover takes a very long time, but the trajectory doesn't differ that much from standard thinning. In actual fact, all indication is that you thin a little bit heavier under transformation system to continuous cover. So as a result, you get a reduction in productivity. You're going for the higher assortments in your transformation system, and your carbon capture is going to be lower in the short term. But the minute you hit the clear fell cliff, the advantage of continuous cover are going to come to play out. Unfortunately, in that time frame, there's no data in the UK or in Ireland to calculate it even for timber. So you can't ask me to calculate it for carbon. We're working on a European Investment Bank project to try and answer this question, and a UCD project. But we know that we most probably only talking about the transformation phase, maybe into the natural regeneration phase and the differentiation phase, but not at steady state continuous cover as people think about it.
Okay, thanks, Kevin. I think that probably addresses the last question that's up there as well, in fairness. I think that, oh, hang on, there's another question here. And it probably comes to you again, Kevin. It's from Henry Duggan. With respect to double accounting, if a credit is created and sold to an entity in Ireland, where the entity does not have a compliance liability, does this not prevent the double counting issue?
Right, so it depends where the registry is. So if it's under the VERA or the voluntary trading scheme, it doesn't really matter because the credit is generated in Ireland. It doesn't matter where it's sold. Okay, so there has to be, the registry has to be adjusted in the country where the credit is generated. You could sell it anywhere, obviously, because you're selling it into international market. It'll be very difficult to govern if you try and oversee it to the buyers to show credibility rather than the seller. Obviously, it's easier to have control and verification of the seller. So that's why the standards require that the adjustments done in the land, in the boundary in which the credit is generated.
Okay.
Does that answer the question, I hope?
Well, let's hope it does. I see no more questions. We are gone over time quite a bit. All that remains for me to do at this stage is to thank Gary and David and Kevin for their very interesting contributions on where forestry and carbon is at and perhaps where it's likely to go. Thanks, gentlemen. Excellent contributions, and thanks for the questions. And back to you, Alex.
Thank you very much, Andy, and thank you for looking after us this evening. I think this evening was a really good topic to end our series on. I think you've all made a very strong case for planting more trees. I think you've all given us a sense of urgency that we need to plant more trees more quickly. And I think I suppose, like all the other webinars we've had, like over the winter, we've had people presenting different options on forest management and what we should be thinking and what species we should be planting and how we should be managing our forestry. So hopefully it's given people loads of thought, food for thought of going forward. We've had between 100 and 200 people at each of our webinars over the winter. So I'd like to thank everybody who's joined us over the cold winter months. I'd like to thank all our contributors. So we've had over 50 people contribute, taking time to make presentations, to all our film stars of our short films. They were people facilitated us on sites. It was great. I'd like to thank all the members of the Society of Irish Foresters who helped us along, the staff from the Department of Agriculture, Food and Marine, and I'd like to thank Pat O'Sullivan especially helping us put this programme together. I'll be sending out an email in the coming days just with a link to all the webinars. If anybody wants to look at the recordings, they're all up on our YouTube page anyway. And also, if anyone would like to join any of the local producer groups for field trips over the summer, just drop me an email and I'll put you in contact with your local group. Pori Gotuma asked us to give a mention to the ITGA event, which is on the same time, same bat channel next Thursday. I think it's actually on at 8 o'clock next Thursday. If you check forestry.ie, you'll see it in the calendar. And then I suppose overall, I would like to thank you all again and look forward to seeing you all out in field trips during the summer months out in forestry. So thank you very much, everybody. Good night.